Today we're going to be learning about the product rule, another way to take derivatives. This highlights it very nicely right here. You have f of x times f of u, or f of u times g of u. What you do is you take the first function times the derivative of the second plus the second times the derivative of the first. Easy. Keep that in mind. It doesn't matter which order these are in. Some people memorize it the other way around. This is the way I've always learned it. The first times the derivative of the second times the derivative of the first. Sometimes you can take more than one derivative of a function. You can take the first derivative. If you take the derivative of the derivative, you have the second derivative, and vice versa. We're going to get to some of those on the second page. Okay, so let's start with this first one. Here's my first function. Here's my second function. Say this is f of x, this is g of x. So when I take the derivative, I take the first function times the derivative of the second plus the second function times the derivative of the first. Usually you can stop that way. On the AP exam, the answers will always be simplified, so you need to know how to simplify so you can find the correct answer on the test. So you have 2x squared plus, you got to distribute, 4x squared minus 6x, which is 6x squared minus 6x. And there's your answer. All right. No, you don't have to factor the 6 and the x out. All right, the derivative of this. This is messy. Okay, here's the first one, here's the second one. So you got to write small. So the first function, negative 2x to the fourth plus 5x squared plus 4 times the derivative of the second, which is negative 6x, plus the second times the derivative of the first, plus 10x. And if you FOIL that all out and simplify, you should end up with 36x to the fifth minus 46x cubed minus 30x squared minus 4x. You might want to stop the video right now and do your math and see if you get the same answer. All right? I'm going to skip this one. You can do that one on your own. Solve the derivative. Here's a function times a trig function. Same thing though. The derivative, the first, times the derivative of the second, plus the second, times the derivative of the first. You'll notice I'm using the power rule. So we've got the power rule, now we have the product rule. Okay? More practice. Let's do this one so you don't get confused. The derivative, you take the first times the derivative of the second. Now, remember the derivative of the cosine is negative sign. Put your negative out front, because if you do this, it looks like you're subtracting, and I'm going to mark it wrong. Okay? It means you didn't know what you were doing. Parentheses would help, but just get in the habit. Put your negative out front. Okay, now you take the second times the derivative of the first. So I end up with negative sine squared x plus cosine squared x. Remember, that's how you write squared, or else you can do it this way. It just takes more strokes to do that. Okay? We'll leave that. All right, that one more practice. All right, now we're talking about acceleration. We've got a couple things that we should talk about first here. Generally speaking, in calculus, we use s of t to equal the position function. Position is in feet, okay? Feet, miles, inches, something like that. If I graph position, this is time, and this is distance. When I do the slope, I have feet, okay, so my distance in feet over time in seconds, Okay, that's the slope of this line. Feet per second, miles per hour, inches per minute per day. Okay, something in that. This represents velocity. Okay, this is slope. So what we do is we have the derivative of the position function equals velocity. All right, the derivative of the position function equals velocity. Now if I graph, hang on, we're going to get rid of all this. If I graph a velocity function, I have feet per second, and this is in seconds. When you do the slope, you have feet per second, which is feet per second squared, which is acceleration. Okay? So the second derivative of the position function equals the derivative of the velocity function, which is acceleration. Okay? Think about that a second. Let it soak in, digest. Big concept. We use S for position. The derivative of position gives you velocity. The derivative of velocity gives you acceleration. Okay? Second derivative of the position. Second derivative of the position function. First derivative of velocity. Rate of change in velocity equals acceleration. So here's the problems. The position of an object is defined by the equation y equals 1/4 t to the 4th plus t squared. What's the acceleration at t equals 2? Well, this is your position function. That's what they gave you. And we use t for time instead of x's. If I take the derivative, it gets me to velocity. So 4 times a 4th is 1, so I end up with t cubed plus 2t. And if I take the derivative of velocity, that equals acceleration, which is 3t squared plus 2. And then I want acceleration when t is equal to 2. So you have 3 times 2 squared plus 2. So it's 4, 12, 14. 14 units per second squared. Okay? Most of these problems usually have units on them. Make sure you use them. Okay? This is just kind of a weird question. Very rarely am I going to ask you for the 4th derivative. This is the first derivative. Okay? This is first. This is 4th. So if I take the derivative of that, I'm going to call it f double prime. It's equal to 20x cubed minus 3. If I take the derivative of that, so I've got the third derivative, I'm at 60x squared. I take the derivative of that, you get 120x. Just telling you that you can keep differentiating forever, all right? I don't see the point of that. And so I'm going to skip all those and go down to this problem right here. This is a good problem. This looks like something I would ask you. Okay? Find the derivative. Well, this is function 1, this is function 2. So you have the first times the derivative of the second plus the second times the derivative of the first. You'll notice that's not one of your choices. They factored. I can factor an x out of both of those. You pull out an x, and I'm left with x times the first derivative plus 2 times the function. And that looks like which function? This one. Okay? That's all there is to the product rule. Practice, 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 practice. Because what happens is people forget to recognize that, especially on a problem like this. They forget that it's the product rule. Okay? So go do your homework.